Now that we know how to find all kinds of different characteristics of quadratic equations and we know how to graph them, we're going to talk about a second way to solve them. So in Chapter 8 we solved them by factoring. Now in Chapter 9 we're going to solve them by graphing. Alright, so some key information that you need to know. And we've already talked about this a little bit. Solutions, roots, zeros, all the same thing. Alright, it's where the equation is equal to 0 or where it crosses the x-axis, which we know is also called the x-intercept. So solution, root, 0, x-intercept all means the same thing. Okay, and it's where the graph crosses the x-axis. So for a quadratic, there are three different possibilities. You could have two solutions. Alright, it crosses the x-axis in two places. We could have one solution when the vertex is on the x-axis, that's the only place it touches. And we could have no solutions. If it's above the x-axis and keeps going up, it's never going to touch it. It could also be a situation where if the parabola opens down and the vertex is below the x-axis, that is never going to touch the x-axis, so it would have no solutions. Alright, so review from Chapter 8. Remember, we've done this before. Get one side of the equation equal to 0, factor it, set each factor equal to 0, and then solve. But now, since we know that solutions are also where the graph crosses the x-axis, we can find the solutions directly from the graph. So you can either draw a graph, or we can make it real easy and you can use your calculator. So I'm going to make this real easy, and we are going to graph these on the calculator. So here's my equation, negative x squared minus 3x plus 18 equals 0. It's already equal to 0, so I don't have to do anything. I just need to graph it. So on my calculator, I'm going to go to Menu. I'm going to go down to Graph. I'm going to type in the equation, negative x squared minus 3x plus 18. Alright, press enter, and then I'm going to draw it. So there is my graph, and I can see both of the roots right there, and my calculator is actually going to give me the numbers. I don't even have to try and count and guess if it's exactly on a dot. So if I hit F5 G-solve and then F1 for root, because remember, root, solution, x-intercept, all the same thing, and then it gives me my roots. There's one at -6 and one at +3. So I would write as my solutions x equals -6 and x equals 3. And that's all I have to do. Alright, in this second example, x squared plus 25 equals 10x. Remember, it has to be equal to 0 first. So I'm going to subtract 10x from both sides. There are no like terms, so I'm just going to put it in standard form with the 10x in the middle. And now it's equal to 0. Now I can get my calculator back. Alright, so I'm going to go back to here, and now I'm going to type in my new equation, which is x squared minus 10x plus 25. And I do that, and I draw it, and there is the solution right there. So that graph looks like it only has one solution. Let's double check. G-solve root. It tells me there's a root at x equals 5, and if I press the arrow over, it stays at x equals 5. So that means that graph only has one solution, and the solution is x equals 5. Alright, this last example, I want you to pause here and try it yourself. So get it equal to 0, graph it, find the roots. Alright, so you should have got negative x squared minus 3x minus 5 for your equation, and if you graph it, it looks like this. So notice that the graph doesn't touch the x-axis. Alright, if I hit G-solve and hit root, it tells me not found, because there aren't any. Alright, so remember, we looked at that. When it looks like that and it doesn't touch the x-axis, we say there is no real root, or no real solution, or no real 0. Okay, and we have to say no real because later when you get to AFTA and Algebra 2, you're going to look at solutions that aren't real. I know that sounds really confusing right now. Don't worry about it. Just know that your answer should say no real solution or no real root. Alright, so we did solving by factoring in Chapter 8. We just looked at solving by graphing. I'm going to show you a third and final way to solve quadratic equations, and it's called the quadratic formula. So here it is, x equals negative b. This means plus or minus the square root of b squared minus 4ac, and the whole thing is over 2a. Alright, so when we do that, we're just going to get a, b, and c, remember, from the standard form of a quadratic equation, and we're going to plug them into this formula. So if I look at this example, 2x squared minus x minus 21, the first thing that I want to do is identify a, b, and c. So a is in front of the x squared term, so a in this case is going to be 2. Alright, b is in front of the x term, and if there's no number there, we know that it is a 1. Alright, and then c is going to be what is in front, or the constant at the end, and you have to take the sign into account. Okay, so in this case, a is going to be equal to 2. Alright, b is going to be equal to -1, and then c is going to be equal to -21. So I'm going to plug that in to my quadratic formula. So I have x equals, the first thing is negative b. Alright, -1 is positive 1. Alright, plus or minus the square root of b squared, so -1 squared, minus 4 times a, which is 2, times c, which is -21. Alright, and that is all over 2 times a, which is 2. And then we're going to simplify this using order of operations. It's very important that you follow order of operations. So what I'm going to do is do everything that is inside of the square root first. So I have 1 plus or minus the square root of -1 squared is 1. Alright, -1 times -1 is 1. Then I have -4 times 2 times -21. Alright, and it's important that you treat this 4 as a negative. So -4 times 2 would be -8. -8 times -21 is positive 168. And that is all over 2 times 2, which is 4. Alright, so I'm going to simplify one more time in the square root. So I have 1 plus or minus the square root of 169, because that's 1 plus 168, over 4. Alright, then I keep going. The square root of 169, so I have 1 plus or minus, the square root of 169 is 13 over 4. Now at this point, I am going to split this apart because I have the plus and the minus, so I'm going to do one of each. So 1 plus 13 divided by 4, and 1 minus 13 divided by 4, because remember, a quadratic equation can have two solutions. Alright, so here 1 plus 13 is 14. 14 divided by 4 simplifies to 7 over 2. Alright, 1 minus 13 is -12. -12 divided by 4 is -3. So my solutions are 7/2 and -3. Alright, we have two more examples here, and what I would like for you to do is pause the video now and try them. So for each one, I need you to identify A, B, and C, and then plug those numbers into the formula and solve. Alright, so here's what you got for those two. The first one should have been 4/3 and -3. The second one, the square root of 1025, that's not a perfect square, so you get a number with a decimal. What we're going to do is just round everything to 2 decimals. Okay, so just leave that as the rule for this chapter. Round everything to 2 decimals. Alright. So then I have 32.02, and then when I do the plus, I get 1.85. The minus is -1.35. Alright, so then last thing we're going to look at is the discriminant. If you remember all the way back from day 1, that's the vocabulary word that we skipped. Here's what it is. B squared minus 4ac. So it's the part of the quadratic formula that is under the square root. And here's why the discriminant is so important. It tells you how many solutions there are based on what the discriminant is equal to. So if the discriminant is equal to a negative number, then there are 0 solutions. Alright, and if you think about it, it makes sense because that's the part that's under the square root. So if I get a negative number under the square root, I can't take the square root of the negative number, so then there would be no solutions because I couldn't continue to solve that. Okay, if the discriminant is equal to 0, alright, then there is one real solution. Alright, and again, that's the part that's in the square root. So if I look at the quadratic formula, if this was equal to 0, then it wouldn't matter what negative b was or what 2a was, because negative b plus 0 is going to be the same thing as negative b minus 0. So I would get the same solution for the plus and the minus. So there's only one real solution. And then if the discriminant is a positive number, then there are two real solutions. Okay, it doesn't matter what number it is. If it's a positive number, there are two real solutions. So let's look at this example. All right, 4x squared plus 5x equals negative 3. We got to find the discriminant and the number of real solutions. Well, the first thing I need to do is get it equal to 0. So I'm going to add 3 to both sides. So I now have 4x squared plus 5x plus 3, and I'm going to find the value of the discriminant. So the discriminant is b squared minus 4ac. b here would be 5, so I have 5 squared minus 4 times a, which would be 4, times c, which would be 3. Alright, so 5 squared is 25. Negative 4 times 4 is 16, and 16 times 3 is 48. Alright, 25 minus 48 is negative 23. So if the discriminant is a negative number, there are 0 real solutions. Okay, so make sure you fill in b squared minus 4ac as the discriminant on that table from the first 2 pages when we did all of the other like axis of symmetry and vertex and that. Make sure you fill that in on that table, and then don't forget the Google form. If you have any questions, please write them down and or put them on the Google form.